So that first day in Chapter 12 for us was just really review of algebra skills that we're going to need to use. From today forward, we'll be doing the geometry concepts in this chapter. And the first things we're going to talk about in this chapter, geometry-wise, are circumference of a circle and arc length. And circumference we'll review, but circumference is the distance around a circle. It's what we call perimeter in all other shapes. And arc length is just a piece of that. And then we'll also be talking about areas of sectors. And to do that, we'll talk about the area of a circle. And then a sector is just a piece of a circle. Okay, so let's begin with circumference. As I just mentioned, circumference really is the distance around a circle. So if we were to measure this all the way around this circle, that would be the circumference of that circle. There are two commonly used formulas. Circumference equals pi times diameter is this one. And then the one we'll use most often is the one on the right here. Circumference equals 2 times pi times the radius. So let's just review finding circumference of a circle. In number 1, they ask us to find that circumference. They do say leave it in terms of pi, so that's going to be an important thing. And I'll tell you why when we get to that. They did give us the radius, 50 inches. So we'll use the formula circumference equals 2 times pi times the radius. And we'll substitute in 50 inches for that radius. Now what it means when they say leave it in terms of pi is that we do not put the pi into our calculator. So if we put the 2 times 50 in our calculator, we get 100 and then pi and then inches. The label is inches. Do not forget, you must always box your answers in this chapter. Now, this one said to leave the answer in terms of pi. Sometimes they will ask you to round your answer. Let's do one of those. So in number 2 here, once again, they've asked us to find the circumference. This time they say round to the nearest hundredth, and they gave us the radius again. Radius was 10 inches. So we use that same formula, circumference equals 2 pi times the radius. We fill in, for the radius, 10 inches. And this time we put that entire thing into our calculator, and nearest hundredth is 2 decimal places. 2 times pi times 10 gives us 62.83 inches. Do not forget the label, and do not forget to box your answers. Well, you found circumference before, so what's new in geometry? What's new is we'll be finding just a piece of this circumference. And a piece of the circumference is called the arc length. Now, since it's just a piece of the circumference, we're going to be finding a fraction of the circle. And we're going to take that times the 2 pi r, the formula for the circumference of a circle. Now, back in Chapter 11, the chapter we just tested on, we learned that the measure of an arc AB, will be equal to its central angle, so 40 degrees. If I am looking for the arc length, which we'll just use an L for, we need to take the fraction of the circle, and the fraction of the circle would be 40 degrees out of 360 degrees, times 2 times pi times the radius. The radius was given to be 6 centimeters. Now this one again asks you to leave it in terms of pi, which means you will not put the pi into your calculator. You will put in the 40 divided by 360 and the times 6, and what we end up with is 4/3 pi, and the label would be centimeters. That's our arc length. Now, just as we did with circumference, sometimes they will tell you to round this. They won't want it in terms of pi. In terms of pi is when they want an exact answer. That's when you leave it in terms of pi. If they ask you to round, which they did on this problem right here, round to the nearest hundredth, find the arc length. We need first the arc measure, the measure of that arc. A to B will equal the central angle 150 degrees. So to find the length of the arc, we take the fraction of the circle, 150 degrees out of 360 degrees, times 2 times pi, and again, they gave us the radius, 8 inches, so times 8 inches. And this time we'll put all of that into our calculator because we're going to round it. And we get 20.94 inches. That's how you find arc length. Now, occasionally, they will give you information about the arc length and ask you to find the overall circumference of the circle. That's what's happening here in problem number 5. They ask us to find the circumference, and they give us the arc length. When they ask you to find the circumference and they give you the arc length, what you're going to do is you're going to use a proportion. And we're going to compare the part of the circle which is the arc, to the whole circle. Now, just to remind you, we're comparing the part to the whole. So to begin with, we have the degrees in the part. So we have 20 degrees in the part. A full circle, the degrees is 360. On the other side of the proportion, we have the arc length for the part. So that goes on the top. And we're looking for the overall circumference. As we've done always before, you solve proportions by cross multiplying. 20 times c would be 20c. 360 times 24 gives us 8,640. To finish solving it, we'll divide by 20 on both sides. We come up with the circumference equals 432 centimeters. Whenever you're given information about the part of the circle, the arc length, and you're asked to find the circumference, that's when you'll use proportions and cross multiply. Let's try another one of this type. So here yet again, they've asked us to find the circumference. They've given us the arc length. So we're going to use a proportion. And we're going to compare the part of the circle to the whole circle. This is the number of degrees in the part. So 100 degrees goes on top. 360 degrees is the degrees in the whole circle. This is the arc length in the part. So 56 feet is going to go on the top. And we're looking for the whole circumference. Let's go ahead and solve it by cross multiplying, of course. 100 times c, 100c. 360 times 56, 20,160. Divide by 100 on both sides. Circumference, 201.6 feet. Pretty straightforward. Very good use of proportions. Let's try a different type of problem. Let's talk about area. Now, we have found the area of a circle before in geometry, and you learned this long before. The formula is area equals pi r squared. Let's just review one of those. Now, in this problem, they actually didn't give us the radius. We know we need pi r squared, but they gave us the diameter. So we first have to find the radius. Well, the radius is equal to the diameter divided by 2. So the radius would be 4 feet. And now we'll put that into our formula. Pi times 4 feet squared. It asks us to leave it in terms of pi, so we won't put the pi into our calculator. We'll just go ahead and multiply that out. Area equals 16 pi feet squared, just as we've done before. Now, sometimes they will have you round, so let's take a look at a problem where we have to round. In this problem, they once again ask us for the area of the circle, so we know we're going to use pi times radius squared. They did give us the diameter was 9, so we'll have to first find the radius. 9 divided by 2, so the radius would be 4.5 centimeters. We'll put that into our calculator. Area equals pi times 4.5 squared. And this time, since we're rounding to the nearest hundredth, we're going to put the whole thing into our calculator. We end up with 63.62 centimeters squared. Okay, let's talk about the new thing, the area of a sector. A sector is just a piece of a circle. So this green part you see here is a sector. It looks sort of like a slice of pizza. Once again, we have the fraction of the circle. But this time we take it times pi r squared, the area of a circle formula. So down here in number 9, they ask us to find the area of the sector. They want us to leave it in terms of pi. They've given us the degrees for the sector, and they've given us the radius. So to get the area of the sector, we'll take the fraction of the circle, which is 135 degrees out of 360 degrees, times pi, times that radius squared. Since it says in terms of pi, we will not put the pi into the calculator. We'll put everything else into the calculator. So for the area of the sector, we come up with 54 pi centimeters squared. We always have to box those answers. And of course, they're not always going to ask you for an exact answer. Sometimes they'll ask you to round your answer. So let's try one where we have a rounded answer. In number 10 here, they ask us to find the area of the sector. They've given us the degrees of the sector, and they've given us the radius. But this time, we're going to the nearest hundredth. So for the area of the sector, we need the fraction of the circle, 60 degrees divided by 360 degrees, times pi, times that radius squared. And we'll put all of it into our calculator. And for the area of the sector, we get 33.51 inches squared. Now, just as happened with arc length and circumference, sometimes they'll give you information about the sector, the area of the sector, and they'll ask you to use that to find the area of the whole circle. In this case, we'll use proportions again. Let's take a look at one or two of those. So here, they ask us to find the area of the whole circle, but they gave us information about the sector. Degrees in the sector, area of the sector. So we will use a proportion. And we will compare. Sorry about that. We will compare the part to the whole circle. So for the part, we know the degrees are 45. For the whole circle, we know the degrees are 360. For the part, we know the area is 25 centimeters squared. And we're looking for the area of the whole circle. And that setup is pretty routine. When we cross multiply, we get 45A equals 360 times 25 gives us 9,000. We divide by 45 on both sides, we get 200, and the label would be centimeters squared. These proportion problems should not be that difficult at all for you. Let's try another example. Here you're asked for the area of the circle. You're given the degrees in the part. And you're given the area of the part. So you'll use a proportion. And you'll compare part to the whole. Degrees in the part, 80 degrees. Degrees in the whole circle, 360 degrees. Area of the part, 64 square feet. And we're looking for the area of the whole circle. Pretty straightforward. Cross multiplying, 80 times A, 80A. 360 times 64, 23,040. Divide by the 80, area comes out to be 288 square feet. These proportion ones I think you'll find to be even easier than the other ones. Number 13. Now, number 13 says, use the arc length to determine the radius. So they've given us the arc length. They've given us the degrees in the arc. So L is equal to 16 pi. That means I can set it up 16 pi equals 36 degrees out of 360 degrees times 2 pi r. We're using the arc length formula. Every time you have a problem like this where you have that fraction, I suggest you eliminate fractions. We would eliminate fractions by multiplying by 360 on both sides. On the right side here, we'd still be able to take 36, 36 times 2 pi times r, and over here 360 times 16 gives us 5,760 pi. And now we'll divide by everything except the r. 36 times 2 pi. 36 times 2 pi. On the right side, the only thing left is the r. On the left side, when we put that into our calculator, don't forget to put a whole parenthesis around that bottom. And we should put a parenthesis around the whole top. And that works out to be 80 centimeters. There's our radius. One more problem like this. One more practice one. So here, yet again, we are asked to use the area to determine the radius. Here we have the degrees in the sector. And then, of course, the area of the sector. So 588 pi goes in over here. 120 degrees divided by 360 degrees. Since it's area, we have pi times radius squared. Let's eliminate the fractions. So we'll multiply by the 360. The 360s cancel. We have 120 pi r squared. And then 360 times 588 gives us 211,680 pi. To solve that, we'll divide both sides by the 120 pi. On this right side, you can see that everything now has canceled except r squared. And this is what we have on the left side. The pi's will cancel. Just 1 second here. But we have to take the square root of both sides. So what we're going to enter into our calculator is this. And it asks us to, well, that actually works out to be 42 or negative 42. But 42 does not make sense, or negative 42 does not make sense because radius cannot be negative. So that's our answer. That last one was probably the most complicated one. I hope this section made sense. Again, we talked about arc lengths and areas of sectors. So good luck in your regular geometry. Remember, you're welcome in my help sessions from 2 o'clock to 4 o'clock each school day.